We will now do an application on chapter 3. Now, this is the type of long question you could expect that deals with a bit of mathematics, a bit of graphing, and your conceptual understanding. We are jumping ahead to some extent because the math application of chapter 3 will be taught next week, week 4, in the ECO235 course. But I thought, for the sake of us having done or completed chapter 3 this week, let us work through an example. So here we go. Right, you are told that Max derives total satisfaction from consuming magazines and newspapers. So there are two goods, magazines and newspapers, and we're going to use the letters M for magazines and N for newspapers. And you are given a value to denote the total satisfaction or utility he's going to get from the consumption of those two goods. And you are told that it's 250 utils. And then you are also told this is expressed by a utility function. So U represents that utility function. And that function is given by or a function of magazines and newspapers. And it is equal to 5 times MN, right? So utility is 250 utils. So that is essentially your left-hand side there. U is equal to 250, but the function is given as 5 times NN. So if you needed to graphically illustrate this utility function, which you are going to be asked to do, it is important to note what would be on your x-axis and what would be on your horizontal axis. Now, you know that when you need to graph a function, coordinates are always given as x and y. So this first variable m would represent your x value, or the variable that would be on your horizontal axis, and that would represent the variable that would be on your y or vertical axis. Now you are told that he allocates his income of 200 Rand between the two goods. So magazines have a price P of 20 Rand, and newspapers have a price of 10 Rand each, and his income I is 200. So the first question asks, derive and graph the linear equation. So linear equation, you know, straight line for the budget line. So using this information, can you derive the linear equation and graph it for the budget line? B is slightly trickier. It says graphically illustrate the indifference curve. Now here you have your function for your indifference curve. So can you use that to graphically illustrate your utility or your indifference curve? And then C says, find the utility maximizing combination of the two goods. So what combination of magazines and newspapers would maximize Max's total satisfaction, given that he has an income of 200 Rand and that he has to consider the prices of the two goods? So that is the point of tangency between the indifference curve, the utility function U is equal to 5 times Mn, and the point of tangency between that and the budget line. And that is going to give you that point where you can determine how much of magazines and newspapers would maximize his satisfaction. So let's begin. So for A, it's fairly straightforward. You are given the income I, and that was 200. You're told that the price of magazines M is 20 Rand and the price of newspapers N is 10 Rand. And from section 3.2, you know that your budget constraint is given as I for income is equal to the price of your good M times M, the quantity of magazines, plus the price of the other good, which in this case is newspapers, times the quantity of the newspapers. So we can substitute the information we have to obtain our budget line or that constraint. I is 200. Our price of magazines we saw was 20 Rand, and our price of newspapers we saw was 10 Rand. We don't know the quantities of M and N yet, that we need to figure out. So, by virtue of the fact that I told you, when you look at a utility function, you can see which variable needs to be on the x-axis, your horizontal axis, and your vertical axis. We saw, if I quickly go back, that your utility function, m, would represent that x coordinate. So, magazines will be on your horizontal axis, and newspapers will be on your vertical axis. Now, we know that when we graph a linear equation, a straight line equation, y equals mx plus c. We have our y on the left-hand side, and in this case, our y is newspapers. So we need to rearrange this budget line equation such that our y, which in this case was n, is on one side, or the subject of the formula. So here we have our original budget line. If we take the 20m over, it will become minus 20n. The sign changes when you take it over. We still have 10n on the right hand side, and of course all we want for it to be in that form y equals mx plus c is that n is on its own. So now we can divide all of these terms by n, and what we're going to get is 200 divided by 10 is 20. We have a negative divided by a positive will be negative 20 divided by 10 is simply 2. So we have 2m equal to n. And there is your straight line, your linear equation. So very easily you would be able to graph this because you could see, right, that is your vertical intercept, minus 2 is your slope, and you can substitute coordinates for n and m to determine various coordinates to plot the line. You could set n equal to 0, determine what m would be, and similarly set m equal to 0 to determine what n would be. So just simple plotting of your straight line, right? Next, point B asks that you graphically illustrate your indifference curve, your utility function. Now, your utility function was given as U is equal to 5 times mn. But you're also told that his utility was 250 utils. So U is 250, so I can substitute that. Therefore, I can say 250 is equal to 5 times mn. And of course, I can simplify that. So I can get rid of that 5, divide both sides by 5. I get 250 divided by 5 is going to give me 50 equal to mn. So if we needed to plot this indifference curve, what we're going to do is we are going to substitute different values for n to determine what the corresponding m coordinate would be. So if n was equal to 25, we could easily see that m would be equal to 50 divided by 25. That would be equal to 2. Also, if n is equal to 10, now substitute 10 in for n, we can now see that m corresponding coordinate would be 50 divided by 10, it would be 5, and so forth. Lastly, let's just take this one. If n is equal to 2, n is equal to 2, 50 divided by 2 is 25, so m is equal to 25, right? So using these, you can plot your convex shaped indifference curve. The next question is the application that you would see in ECO231 as well as ECO235, which we will do next week. Now, here you are asked to determine what combination of magazines and newspaper would maximize Max's utility. So we know that utility is maximized from chapter 3, where your marginal rate of substitution is equal to the ratio of the prices. We know that the ratio of our prices, magazines was 20 rand and newspapers was 10 rand. So 20 over 10 can be simplified to be 2 over 1. We know that our marginal rate of substitution can also be given by the ratios of our marginal utilities. Now, here's another trick to take note of. Did you notice that when you looked at your ratio of your prices and your ratios of your marginal utilities, that in the numerator, you had the good that was on the horizontal axis in both instances? So from chapter 3 in the textbook, you had your price of food in the numerator where you had your ratio of your prices, and you had the marginal utility of food in the numerator where you had your ratio of your marginal utility. So it's always the price of good X over the price of good Y, and the marginal utility of good X over the marginal utility of good Y. And that can be proven algebraically. But for this course, you don't have to go through that, but it is important to note that. So our good on our horizontal axis is magazines, and I'll also explain to you why that is the case in this example. So magazines was our good on our horizontal axis. So it is the price of M over the price of newspapers. And also for our marginal rate of substitution, which is also equal to our ratio of our marginal utilities. We saw that in section 3.5. It is going to be our marginal utility of magazines over our marginal utility of newspapers. Now, you weren't shown how to derive your marginal utilities from a utility function using partial differential calculus. Now, you were given your utility function, and that was given as your utility function is equal to 5mn. That was the utility function. So to get your marginal utility, we need to do partial differential calculus, which you'll be learning in ECO235 this week. And this sign, this curly D, is the sign that tells me I'm performing partial differential calculus on my utility function with respect to M holding n constant. So you would get, if you were to partially differentiate your utility function with respect to m holding n constant, it means that that function u is equal to 5mn. You differentiate the m part, and m had an exponent of 1. Thus, when you differentiated that, it would just be 1, and you'd be left with 5n because it's multiplicative, so it is a multiple thereof, so you're left with 5n. I will explain this more thoroughly this week in ECO 235, so bear with me. And here in the denominator, you have your marginal utility of newspapers, which is given by the partial derivative of the utility function with respect to n, holding n constant in this case. So thus you have your function u was equal to 5mn, but you are differentiating the n in that utility function, and n was raised to the power of 1. So hence you just left with 5m. And of course the 5's can cancel. So hence you have n over m as being your marginal rate of substitution. And now your ratio of your prices was 20 over 10, the price of magazines over the price of newspapers, and that can be simplified to be 2 over 1. Thus, at that utility maximizing condition, you saw that was where your marginal rate of substitution, which is given by your ratios of your marginal utilities, which we saw was n over m, right, is equal to our ratio of our prices, which we saw was 2 over 1. And now we can just rearrange such that n is the subject, and therefore that is going to be n is equal to 2m. So now we take this, and remember we want to find that point of tangency where your slope of your indifference curve is equal to the slope of your budget line. So we want to find what is magazines and newspapers equal to at that point. At that point, if we substitute this into your equation for your budget line, which we derived earlier, we substitute n is equal to 2m over there. And by solving, we can take that 2m over, we get 4m equal to 20. Hence, m is just going to be equal to 20 divided by 4, it is equal to 5. Now let's solve for n. And we saw that n was also equal to 2m, so we could substitute n in for 2m. We take that n over, it becomes 2n. 2n equal to 20, hence n is going to be equal to 20 divided by 2 is 10. Or you could say m is equal to 5, and 2 times 5 is 10, and 20 minus 10, n is equal to 10. You are now able to plot your utility function or your indifference curve u is equal to 5mn using the coordinates and points that you found in part B of this question. And you're also able to plot your budget constraint or budget line using part A of this question. You had your vertical intercept and you could determine your slope. Now point B is the point where utility is maximized. That is where your marginal rate of substitution is equal to the ratio of the prices, which is equal to 2. And the optimal combination of goods you just determined was 5 magazines and 10 newspapers. So given Max's budget constraint, he had an income of 200 and the prices of the two goods. This is the optimal combination of magazines and newspapers to satisfy him.